Okay, it's recording now. I'm still letting some people in, but let's get started with 4 minutes in. Okay, welcome all, welcome back. It's another Core Devs call. As always, this is a monthly call with the Graph Core contributors, or in other words, Core Devs. All of these calls are recorded and uploaded to our YouTube channel, so I'll just leave the link in the chat if you want to check the previous ones. And as always, you're all more than welcome to join all of these calls and get the chance to ask core devs some questions and participate in these discussions. You can always also go to our website that's listed in this slide. I'll just share a link as well. And there you can see the Core Devs workspace, our ecosystem calendar, so you can subscribe and join future calls. So a quick update on MIPS, and then we'll get into the Core Devs updates and discussion. This MIPS is the foundation program to bootstrap new support for new chains on the network, and we are incentivizing indexers to help us get there. We started with Gnosis chain. It's ongoing. That's what we're calling the phase one. We've had around 400 people participating, and they are still participating, which is pretty good. Right now, we're focusing on adding robustness to the network, meaning that because we're now supporting multiple chains, there's new components like the epoch block oracle that we've been covering here. And we need to make sure that everything's working properly before we go on to mainnet. That's why all of this testing is happening on the Graphs Curly testnet. So that's the main goal of this phase one, really, is to monitor QoS and ensure that we are ready to serve Gnosis properly on the network. And that will be phase two, which is imminent. So do keep an eye on the program and check your emails if you are participating. Yeah, and this will never be possible without the MIPS participating and sharing their feedback on the program. So appreciate you all. This is how we can get ready for mainnet. Quick overview of the agenda. So today we will go over Scalar. As you know, Scalar is a micro transaction solution previously built on the Connect Vector protocol for query fees on the network. It's been recently redesigned to support some solutions like homomorphic encryption and thus removing implicit trust in the process. Zach will share more updates here for sure and share more the recent achievements coming from the research team. Then we'll have Brandon Kramer from Edge and Node, who's been working on upcoming improvements to the Graphs building user experience. Yeah, that's like this. We've all been dedicating quite a bit of time to this, so I think it's worth going over this, and I think we'll get some like 20 or 25 minutes for this particular session. Lastly, related to L2 migration, which we've been covering here, it's a big topic for this year. Pablo and Ariel will share the results of the results of the security community audit and how we are in terms of GIPs to get L2 ready. And then lastly, still on GIP is actually a quick overview of changes coming to the protocol and state of dependencies related to unlocking multi-chain indexing rewards on the network, and that's going to be from Adam. I'm leaving some time for Q&A and open discussions, and also during all of these topics at the end, if you want to participate and ask questions, just raise your hand. I will unmute you and you'll be able to ask your questions away. So yeah, it's a big agenda. Let's get started. I'm all done. I'm going to stop sharing, and I believe Zach is first. So Zach, do let me know if you can share your screen.
Okay, we're good. Yeah, you can see my screen. You can hear me. Everything's good to go. Perfect. All right. So the purpose of this segment is to update the community on the work that has been happening behind the scenes on Scalar, which is the Graphs fee system. Just as a quick refresher of what Scalar is that Scalar enables fees to flow from gateways to indexer. We had to roll a custom fee system rather than use any of the off-the-shelf state channel solutions because we couldn't find any state channel solution that would scale to the needs of the graph. So in the graph, every query is enabled by a fee. And the hosted service is serving more than 1 billion queries per day. By comparison, Ethereum is doing about 1 million transactions per day. So we would need about 1,000 times that capacity today to just account for query fees, not accounting for future growth of the graph. So that's a lot of fees that we need to support with this system. Not only did we need, to support all this throughput for the 1 billion queries per day, but we also needed something that's highly concurrent, because many requests are happening in parallel using the graph. And the way that state channel systems, including Scalar, deal with this is to just spin up more state channels as more concurrency is required. So that's how Scalar works. And then the last thing that we would really need for Scalar to be able to support the graph is a highly efficient dispute system, which no other state channel system has. So efficient disputes are essential because an indexer needs assurances that if they serve queries, they're going to receive those fees. Even if a gateway goes offline or refuses to cooperate, they don't want to trust that gateway is going to pay them the fees, right? Because they're incentivized to hold on to their fees. So they want to be sure that even if the gateway is not cooperating, that they can collect those fees anyway. And what I want you to notice about these design goals is that highly concurrent state channels and efficient disputes seem to be at odds with one another. And these are the things that we need Scalar to be. So this is a problem. So if we're solving the problem of parallel requests by spinning up lots of state channels, then the more state channels that you have, the more you have to do on chain when there's a dispute, because each of those state channels that you spun up needs to be disputed on chain at a cost that is typically linear in the number of channels, just becoming more and more expensive the more parallelism that you are enabling. And because of that, as of today, Scalar is considered incomplete. We're not really satisfied with the cost of disputes. And Scalar does have the most efficient dispute system of any state channel protocol that exists. But even the best is not good enough for the graph, because at the ginormous scale that we need to support, it's still cost prohibitive under a lot of circumstances. So you may recall that at Graph Day, we announced a novel experimental snark called shell proofs. And the goal of shell proofs was to solve this problem. The idea is that instead of posting all of the dispute data for every state channel on chain, we could make disputes much cheaper by posting a succinct proof that we had knowledge of all of that data. And that would take the cost of on-chain verification from linear to sublinear in the number of disputes, greatly reducing the cost. And the work on shell proofs is ongoing. Cryptographers at Edge and Node and Semiotic are working full time to bring shell proofs out of the proof of concept stage and into production. And there's a lot of work necessary to do that, including publishing papers for academic peer review, developing a compiler, and just lots of places to cross our T's and dot our I's to get this over the finish line. But in the meantime, the exciting thing that I want to share with you today is that the cryptography team at Semiotic has come up with an even better approach than snarks to deal with this problem of efficient disputes in Scalar. Now, snarks are great, but one of their key advantages is also their weakness in that they are general purpose tools. They're designed to solve any compute problem that you throw at them. As engineers, we know that there are advantages to bespoke solutions, solutions that are designed to exactly fit the specifications of the problem that you have, right? That's why there's not just one power tool in someone's garage, not just a hammer or just a screwdriver or just a saw for all problems. We have many different kinds of tools for many different jobs. And what they came up with is something that is simpler, resizable, has a cheaper verifier, a cheaper prover, and faster to market. So better across pretty much every dimension. And what I mean by simpler is that the cost of engineering and maintaining this solution is going to be much lower. There's less cognitive overhead for the core devs or people who are involved in using this system. It's resizable. One of the problems that we had with snarks is that you have to choose ahead of time how many state channels that you're going to support. So we wanted to get up to, say, 1 million concurrent state channels, but then we would have to bake in that number potentially forever, that 1 million state channels was just going to be the number that we supported, and never more than that. But with this new solution, it's resizable. So if we happen to use 1 million state channels and need more, well, we can just grow the solution to support that number of state channels. And if we need less than 1 million state channels, well, we don't have to be paying the cost for 1 million at all times. We can start off with a much lower number and grow as we need. Also a cheaper verifier, which is the cost that the indexer pays on chain whenever they're going to be collecting fees. And this is cost savings that can be passed on to consumers. A cheaper prover, one thing that was very difficult to overcome with the snark solution was that when we wanted to generate a proof, it meant having a large amount of infrastructure, maybe depending on the system, up to maybe 2 terabytes of RAM that you just had to have available to you for a few hours to generate one of these proofs. And the costs for that kind of system add up in a non-negligible way that people would notice when using the graph. And then, finally, something that's faster to market. We love our snarks, but we have real problems that we're trying to solve today. So if we can get something out the door sooner with all these properties, that would just be, a win for everyone. And what they came up with is a holographic homomorphic signature scheme, which is, quite a mouthful. So they've, helpfully abbreviated that to just H2S2, which is a working title. This is not a marketing update. This is just an update to the community about where things are at. So H2S2 is kind of what we're calling this thing internally. And what it does is to take advantage of the structure of homomorphic signatures and map that structure to our problem. Cryptography is always complex, but the key insight of this scheme is very straightforward. So I'm comfortable, just going over it on this call here. The key insight is that with homomorphic signatures, messages are aggregated by taking their sum. And the piece of data that we want to extract from the proof is the total amount of query fees that are owed to the indexer. So that's the sum of the fees in all channels. So if each channel is only a fee and a signature, then we can extract the total fees basically for free with this scheme, because the aggregated message just happens to be the total number of fees. And that's the data that we wanted to get out of it. And so, if we have that data, all we need to do to verify the proof is just verify a single signature, and we have our succinct proof. Like, that's it. No complicated polynomial math with snarks and whatever. It's just like very easy to understand what's going on here. I am glossing over a lot of detail, but the core idea is just that simple. And because it's so simple, we think that we can deliver this solution much faster than any snark-based or snark-powered solution. Why do you care, right? As a member of the community graph, why is this update exciting to you? First, the efficient dispute resolution is going to be cost savings, and those savings are going to be passed from indexers on to consumers. And ultimately, lower cost means that we can enable more economic use cases, powered by the graph more efficiently. Make that long tail of use cases, can be enabled if the graph is cheaper to use, which this solution provides. But another benefit that might be a little less obvious is to scale out the role of the gateway and who can operate a gateway. The reason that we can do that is that today the Graph Council approves gateway operators. And they have to do this because of this trust, this implicit trust between the indexer and a gateway, that when an indexer is going to serve queries, they want to have assurances that they can collect their fees. But if the dispute resolution mechanism is not efficient, then that trust is just based on delegated trust from the Graph Council, that the Graph Council is responsible for vetting these gateways and choosing gateway operators that are long-term incentive aligned with the graph. And that delegated trust system works, but it's not ideal. What we really like is to be able to allow for more gateway operators to participate in the network. And so what we're really doing here is replacing the trust that is delegated by governance in the Graph Council with trust that's built on mathematics. So we can scale participation in the graph, and in particular scale participation in the role of the gateway using incentive systems. That's what the graph is all about. So thanks. That's all I have for my update today. Do we have any time for questions?
Yeah, thanks, Zach. Yeah, we can leave some time for questions. As always, as I mentioned, do raise your hand if you want to speak. Okay, I'm not seeing any raised hands. Oh, there you go, Simon.
Hello. Quick question: like, if the state channels are between the gateway and the indexers, so it will be one between each gateway and indexer. So if you have 10 gateways and 1,000 indexers, then there needs to be 10,000 state channels. Am I correct?
It's actually much more than that, because we have concurrent requests between any gateway and indexer. So that can mean thousands of state channels between a single gateway and indexer. So we really need a system that scales, well beyond what any existing system does today. In fact, we've seen in the high hundreds of thousands of state channels between even single gateways and indexers, because of the graph being geographically distributed all over the globe, and we don't want to have separate collateralization for each of these relationships. And the system needs to be robust and fault tolerant for failure, which means spinning up even more state channels. So there's a lot of state channels going on at any given time.
Thanks.
All right, thanks, Simon. Great question. I don't see anyone raising their hand, so we can proceed. And again, we'll have some time for Q&A, hopefully, by the end of all these sessions. We can continue. Great. BK, you ready?
Sure. Right, so you should be able to see my screen.
Yep, we are.
Perfect. Okay, so yeah, I'm gonna chat. Hopefully I won't reach that 25 minutes, and there'll be time for questions for both this and for Zach's if anybody else has any questions. But I'm generally gonna cover what the upcoming improvements are to the Graph's billing UX. This is part of a general kind of initiative that we have where we're looking at how to strategically improve a number of things about the graph. The main three things that we've been focusing on over the past maybe 2 to 3 months or so have been, first, improving the billing and payment UX. Basically, users are experiencing a lot of cognitive complexity when making payments, and this is specific to like the actual billing flow. When they're going through and clicking to make payments each month, it's complex. There's too many steps, and there's a number of ways that we have identified to improve that. The second thing here is price predictability. This is basically the notion that users are having a difficult time and experiencing too much cognitive complexity when trying to make a budget each month to determine, what are my queries fees going to be? How do we think about curation in relation to this, et cetera? So that's kind of our second initiative. And then the third thing here is around network quality of service. And it should be no surprise that obviously we want to make the graph network not only reach parity, but eventually surpass the quality of service that's offered by the hosted service. So I think all three of these things kind of are really intertwined. But today I'm going to be focusing mostly on billing and payment UX here and talking about the things that we're doing to improve that. So if you're not familiar with the billing flow, just say that you deploy a subgraph, you're making queries, and you accumulate a bill over the course of a month. And you'll have this notification in Subgraph Studio that says, you have a certain amount owed. And then you have to go in and pay your bill. So the way that you do that, you'll go into Subgraph Studio and you'll click and a modal will come out. And these three general sections appear in this modal. In the first section, it tells you that you need to buy GRT and Ethereum. The GRT will cover the queries and the ETH will cover the transaction costs. In the second box here, you see that you'll have to move that GRT from Ethereum, where GRT typically is, over to Polygon to pay that bill. And here we keep our billing contract on Polygon, mainly to try to kind of streamline some of the costs for collecting payments on our side. And then the last step here is you need to add GRT to your billing balance. And this is kind of two steps where you have to allow GRT access and then add GRT access. This usually only occurs the first time that you make these payments, but then after that, it doesn't appear anymore. But obviously there's a lot of steps in this process, and we think there's an obvious way to try to streamline some of these things and make it easier to go and pay your bill on a monthly basis if you're a consumer. So the three main things that we're looking to implement are mainly related to kind of each of these steps, and I'll show you what that looks like in the next slide. But let me explain each one of these first. So the first step is this notion of abstracting the billing bridge for consumers. As you saw in the last slide, that kind of the middle area there in the slide shows that users need to, after they've purchased GRT, they will have to go and bridge that over to Polygon. So what we're working on implementing, and this will be possible to do after we've shifted to Arbitrum, or at least made the billing bridge available on Arbitrum, is really on the back end. We'll kind of make this shift from moving the billing contract from Polygon, where it currently sits, over to Arbitrum. And this is because we're moving the entire protocol over to Arbitrum. So it makes sense to also move the billing balance over there. So that won't affect many users, but in the process of doing that, we can also abstract the bridge that users need to use every time they make their payments. And this will essentially allow users to there's still a bridge there on the back end, but they won't have to experience that when making payments. Instead, users will have one button instead of those kind of three different buttons. So rather than bridging, waiting, adding, or allowing GRT and then adding, this will just be one step that they'll click, and that all will happen kind of in the same transaction or same set of transactions. The main point is that users won't really have to experience that time-consuming and many step process. Instead, that will be streamlined. So that's really the first step. Again, we'll be able to do this once we've moved the billing contract over to Arbitrum, which happens after the billing after the general bridge from Ethereum to Arbitrum is enabled. So we're hoping that's coming soon. We're kind of just waiting on the final steps for that to happen. So the second thing, which is something that I'm really excited about, is the fiat on-ramp here. And so I won't announce any specific partnerships that we have, but hopefully this will be coming soon. Generally, the idea here, though, is that users will be able to access a fiat on-ramp that replaces that first step. Right now, we ask users to go over to Coinbase or Binance or another centralized exchange, buy GRT, and in some cases you may have to wait maybe a week or something like that to even get GRT back over to your wallet. In some cases, there are limitations there on what you can actually transfer. Instead, we want to make a fiat on-ramp available kind of in that payment flow. So this option will essentially allow users to go in, they'll be able to click, they'll go to a fiat on-ramp, and then be able to purchase GRT directly there. Two cool things that we're working on implementing is typically with a fiat on-ramp, when you buy an asset, it will be sent to your wallet. Instead, we're working to implement the option to be able to buy GRT and then directly deposit that to the billing balance. This will prevent a number of other steps after you've purchased GRT to then have to go back to your wallet and make additional steps. This will go directly to your billing balance, And after you've KYC'd, it should just be a 1 to 2 click process to really go in there, buy GRT, and then add to your billing balance. So the main group of users that we're targeting here are trying to are mainly around users that don't want to hold fiat. They want to make payments with credit cards, and this will help streamline that process. While we're not directly allowing payments with credit cards, it's still only 1 to 2 clicks more than that option would be. So this is going to help streamline that process quite a bit. The last section here kind of fits into a different group. In the first group, we have users that already have GRT and Ethereum. The second group is really that they don't have GRT yet, but want to pay with credit cards. This third group is really about trying to streamline those users that have stable coins and would prefer to hold stable coins, but still be able to use the graph without having to hold GRT for too long. So this third option here is kind of optimized for them. This would essentially allow users to have automated and recurring crypto native payments from either wallets or multi-sigs. So what happens here is essentially you could have a wallet or a multi-sig that drips into a wallet. You keep your stable coins or any kind of GRT or non-GRT related crypto asset in that wallet. Over here, you have your billing balance. And you'll be making queries that depend on this billing balance. And let's just say that it gets to a certain point and you want to refill it. This will be 50 GRT that it gets below. And it essentially will send a trigger back to your wallet to drip GRT into this billing balance. So in this case, we'll say 50 GRT is the threshold or the trigger. It will kind of notify the wallet. And then if you have GRT, it'll just directly go into your billing balance. If you have a stable coin, on the other hand, it will be sent to a decentralized exchange. You'll get GRT, and then it'll come back and go into your billing balance. And all of those transactions and kind of cross-chain transactions will be taken care of by implementing kind of a smart contract that will automate that entire process. So in the end, consumers will have kind of 2 different options. They'll be able to either trigger or have a trigger that sets up when your billing balance gets low. It will refill up to a certain amount. In the case that I mentioned before, 50 GRT might be the trigger, and it will increase to 500 GRT to pay the next month of query payments or something like that. The other option is if you just want to drip this slowly in over the course of every week or every month. I believe that option will probably be available too, but that's something we're still kind of debating internally. So in the end, you should see the same kind of flow overall, but each aspect of this flow will be improved. So in the first step, we'll be adding a fiat on-ramp so that you don't have to go, as a consumer, you won't have to go to Coinbase or Binance, but instead you'll have an on-ramp to make those purchases directly in the flow. The second option will abstract that bridge from consumers, so you won't have to bridge from Ethereum to Polygon each time. You will still be bridging to Arbitrum, but that will be abstracted from you. It will generally be the same fee in roughly the same time period that you'll have to wait. But again, there won't be so many clicks, and hopefully this will streamline the process and annoyance a little bit. And the last step kind of applies to all 3 of these. It really generally automates recurring payments so that you can hold stable coins or other crypto assets and kind of automate this process on a weekly or monthly basis so that you don't have to worry about going in to make payments manually each month. So this is essentially like kind of setting or putting in a credit card on another kind of platform and just automating that monthly payment and covering that those query costs. So hopefully that all made sense. Those are the 3 main improvements that we've been thinking about. It's worth noting, though, that we already have a number of other things that we've already either implemented or are close to being implemented as well. So I mentioned previously that when you're making payments, you'll have to bridge GRT from Ethereum to Polygon, and that we're moving over the billing balance to Arbitrum. So it would make obvious sense to say, hey, what if we just made GRT GRT liquidity available on Arbitrum? And that, to the best of my understanding, is something that a number of centralized exchanges have already expressed interest to. So I think as soon as we have Arbitrum up and running, I would expect that pretty soon after that, you'll see GRT liquidity become available on Arbitrum, and that will kind of reduce the number of steps that are required in the payment flow. The second thing here is the email notification system. This is something that we updated, I want to say, over a month ago now. In previous UX research, we identified the need for users to have multiple emails in their account. Previously, users only had one email, and they would get those notifications about a low billing balance to that one email. But obviously, if individuals are within an organization, they may need up to 10 emails to notify other stakeholders within the organization. So we included this new feature, and hopefully that will improve communications around billing. The third thing listed here is this idea of a payment history chart. Previously, we did have kind of like this this list of past payments, but we wanted to improve kind of the understanding of weekly and monthly amounts of past payments in Subgraph Studio. And this is something that I think came out earlier this week or maybe even last. But you can see here if you go into Subgraph Studio and click on billing, and you have past billing balance, you'll be able to now see this a chart that looks something like this. So those would be two different views. If you're looking over the past month, these will show the amount that you paid each week over the course of the past month. Or if you click on the yearly view, you'll be able to see the amounts that you paid over that correspond to each month. There's also a number of important KPIs, but generally the point here is that you'll be able to kind of visualize your past payments more succinctly, and then hopefully be able to translate that into what your price will be in the coming weeks and months. The last thing to talk about here is this query price estimation tool. I'll be forthcoming and say this, this particular feature is kind of still in the works. But generally, the notion is that we want to provide users the increased capacity to make price estimates about billing on the Graph network. Many users will say that it's very difficult to predict what their prices are going to be, especially if they're new to the network. Ideally, we would love the option for users to go in and say, put a query into the playground, for instance, and be able to estimate exactly what that query is going to cost. Unfortunately, it's a little bit more complicated than that because we're relying on a decentralized network of indexers to, kind of vie for what the price is going to be to serve that query. So the best of my understanding, this tool that's going to be introduced is going to be largely available for subgraphs that have already deployed to the network and have a bit of data already. They'll be able to use this tool to put in a price, get an estimate or an average of estimates from a network of a network of indexers, and then from there to be able to make an estimate of how many queries that they'll make over the course of the month. And this will give a general estimate of what that price will be over the course of the month when kind of when other factors like volume discounting and things like that are factored in. So obviously this is complex to implement and isn't perfect, but we really are trying to optimize what we can do for consumers in the short term. And this is one of the things that we have been talking about implementing, and hopefully we'll be close to implementing by the end of the year at the latest. So with that said, really, appreciate any question or questions that you might have, and I'll open the floor.
Very nice. Thanks, PK. I see a lot of clapping in Zoom. Yep. All right, as always, do raise your hands if you want to ask questions. I want to give you the time to do it now. Yeah, people are just clapping. Okay. It's always a nice reaction. Okay. Let's move on then. Again, we did reserve some time at the end for any other business or general Q&A. Yeah, I don't see any raised hands. Let's go. Thanks, PK, again. Amazing work. Really happy to see this coming. And yeah, I'll be glad to try it myself soon, hopefully. Pablo, I believe. Yep. Are you up? You want to take over? All right.
Yes. Hey, folks.
Yeah, there you go.
Can you hear me? Yeah.
Yes, you can.
Cool. So I'm just going to be doing a very quick update on our Code4rena audit contest that we did for the L2 bridge. So this is what we actually presented in the forum and I think on Twitter. Basically, we did an audit contest using this platform called Code4rena that happened in October with 50,000 USDC prize pool. So let me explain a bit more how this worked. We had to prepare a separate repo with all of the code that we wanted to audit, and then Code4rena has a lot of wardens. This is actually a permissionless role. Anyone can sign up to be a warden and behave as an auditor. And the wardens will compete to find and report bugs in the code that we present. And then they would send those bug reports together with gas reports and quality assurance reports, also telling us more about code quality and things that we could do to improve it. And then there is a judge throughout this process in this contest that will look at all of the reports and deduplicate them, assign some severity to them. And then the prize pool that was sponsored by the foundation will be divided among all of the wardens based on the issues that they found, the severity, and there are a few formulas there to make it more Sybil resistant. So more unique bugs are rewarded more. So what did we actually audit here? We took the code we have for the Arbitrum GRT bridge. So this is for our move to L2. And this is what will hold a lot of tokens in escrow in L1 when you're sending them to L2. So we already had an audit for this that was done by OpenZeppelin, and as we often do. But because this is such a critical part of the smart contracts, we wanted to have as many eyes as we could on this. So this was great because it meant like there were a lot of people who had a chance to look at the code and find vulnerabilities and bugs. And this is our first experiment with Code4rena, so it's pretty interesting to have this flexible way to get the code audited by a lot of people and quite quickly, because the time to set up the audit contest is actually quite fast. So some results from this particular contest, we had, I think, pretty good participation. We had 315 submissions. So each submission is either a high or medium severity issue, or a QA report or a gas report. And then after the deduplication from the judge and the severity, and the judge also looks for invalid reports, we ended up having 79 valid reports, which is pretty good. The good news is there were no high severity issues, but there were a couple of interesting medium ones. So what comes next? We already took all of those medium severity issues and the relevant stuff from the QA and gas reports, and we implemented a lot of fixes for that. And in the meantime, the judge is finalizing the prize distribution, and there's going to be a contest report that will be public eventually. So now we're going to have another, or one of these wardens in particular will now review all of the mitigations that we did to make sure that we didn't add any new bugs by fixing the ones from the contest. And once we have approval from the council, and Ariel is going to discuss in a bit more detail all of the steps that we need to do, we should be able to deploy the bridge and finally have the graph on O2. So yeah, that's all I have. Thanks.
Hey. Should I go now, Pedro?
Yeah. So you come in.
Okay, I'm sharing my screen. Yeah, this is sort of a continuation of what Pablo was mentioning. Clearly, we are deploying this bridge to Arbitrum and the protocol contracts in the L2 for all the good reasons that Brandon Kramer explained. Not only about like making things cheaper and faster for everyone in using the network, but also because of like so many UX improvements that we can do with this. Okay. Particularly with the billing and other things. So to give you more of a global overview, already Pablo talked about like the Code4rena community audits. We did an OpenZeppelin audit about the bridge. But apart from that, what we already did is to deploy the protocol on a sort of L2 in the public testnet that is connected to the Goerli testnet that everyone is using today. So those contracts are already connected to the L1, and what is happening now is that the team is running some tests on that public testnet, basically moving some GRT over, trying like I don't know, doing some allocations on the L2, moving things back from the L2 to L1, trying with different gas parameters to see like everything is working properly. The other thing that is happening in parallel is that the council is approving the deployment. And the warden is doing the final like spot check on the changes we did for the Code4rena audits. This is something that already Paulo mentioned. So what's the council voting, right? There's a few GIPs that are related to this deployment. And I'm providing these IDs so you can search in the forum later if you want to dig into the details. But first of all, we have this big, I will say this is in bold because we have a GIP 40 that is sort of a meta GIP that describes the deployment. And it's including GIP number 31 and 39, okay? GIP 31 is basically the proposal of deploying an Arbitrum bridge that is going to manage how the GRT is moved over L1 and L2 with some features that were good to have, like being able to pause the bridge, being able to do some upgrade if it's needed. But apart from that, the GIP 40 is proposing disabling indexing rewards in the initial stage, like indexing rewards in the L2 won't be activated. So for some time to do like proper risk management and everything is people will be able to allocate and curate on the L2, but there won't be any kind of indexing rewards being minted there. And there's a different GIP that is going to propose how to activate indexing rewards. And the final thing is there's a proposal, the GIP number 39, that is proposing flattening the bonding curves on the L2 for all the reasons that you can look in the detail, but basically making things easier for curators, removing all kind of from running and allowing like setting the base for other improvements in the that's it's being worked by the team for curation 2, version 2. So if you're interested in digging into like the details, you can go to Snapshot. This is currently what the council is voting. You can see there are 5, it seems like to be 5 votes for doing the deployment, and it's this vote requires 6 council members. So this is currently active. I took this snapshot from today, so this is happening now. After the approval from the council, the steps are to ensure that the checklist I showed is complete, then setting a date where the deployment can happen. And it doesn't mean that once the contracts are deployed, everything is connected, right? The council needs to do some on-chain transactions to finish the configuration of the bridge, basically connecting L1 and L2, and then unpausing the bridge. So there will be a final on-chain transaction that validates that everything is fine. Okay. Finally, if you want to dig into the details of any of this JP, you have the codes for each of the JP there. You can search in the forum. The important one now is the 40 number, like JP number 40, and it's there. You have the link there. So I'm good with this. Pedro?
Yep. Thanks, Ariel.
Maybe I can answer any question.
Let me monitor some. Not really. In the meantime, and as a reminder, we're also considering testing this as part of MIPS. So there will be like a separate phase where MIPS participants can help us test this out, and as a way to get them ready for mainnet. Yeah, I don't see any raised hands. So let's continue. Thanks, Ariel. Adam, you're up. Do we have Adam? Yep. Make co-host, or you're not co-host. Let me a second. Okay, you should be able to share your screen now and talk. Yep, there you go.
Hey, how's it going? Let me share my screen. Yeah, so as I was preparing for this, so talking about essentially enabling multi-chain on the network, I was reminded of the first time we talked about this initiative, or which I think was so in March of this year. So it's super cool to see all of the progress, and I think we didn't necessarily anticipate all of the work at the time. The devil is always in the detail, but really cool to be, I guess, at the end of this process. So to give a bit of context, we're talking about adding support for multi-chain indexing rewards this is very tightly coupled with the update that Pedro had at the start, just around the MIPS program. Obviously notices this first network that's being added, but that doesn't sort of happen on its own. There are certain things that we're changing, I guess, about the protocol, and so we've got a couple of GIPs which we're sort of moving similarly to Ariel's update towards sort of ratification by the council associated with those changes. So essentially will be required before we can go to mainnet. So really here, I'm not going to go into any of them in too much detail. We want to essentially service them. Again, encourage people to engage on the forum with any last questions, but obviously also happy to discuss here. So the first thing I want to talk about is the arbitration charter. So the charter has been active for some time, but the essentially introduction of new networks introduced a slight change to the charter, essentially in terms of which where the blocks come from when you're closing an allocation, which essentially is a really important thing when it comes to comparing POIs. And so there's some changes to the arbitration charter that are necessary there, but this is also like the first, I guess, formal ratification of the charter by the council. And so, yeah, it'll be great to have that initial version ratified. I'm sure it will change again in the future, as we've obviously learned so much over the last year, and we'll continue to learn as we see more and more essentially disputes coming up and edge cases presenting themselves. But this is the first thing, which is sort of a foundational piece. Similarly, this is also, as you can see by the GIP number, quite an old GIP, but one that's been debated and iterated over some time. What we're doing by introducing new networks is essentially adding more features to subgraphs. And so I think, as lots of people know, there are different features that are not supported at the moment on the network. So IPFS files as part of subgraphs is one obvious example where they can't currently be fetched deterministically, and so indexers can't prove their work through proof of indexing, and so we can't. So the protocol doesn't support indexing rewards. That's something which is going to sort of increase as we're adding more networks, as we're adding more features, and in particular we want to free up or create a clear pathway for core developers to add experimental features to subgraphs, so essentially developers can benefit from new features, but also give the whole ecosystem clarity on what is and isn't eligible for indexing rewards, query disputes. So essentially, like, everyone has a lot more clarity. So there's a lot of detail again in this GIP, and comment and discussion on it is welcome. But I think one of the key artifacts that comes out of this will be a clearer ratification of a sort of feature matrix, which will essentially specify different features that, as they're defined on subgraph manifests, and essentially giving an indication as to their status. So are they experimental or not? And then the level of support across sort of query arbitration, indexing rewards. And so making this a formal thing, which also tracks the sort of latest approved version of GraphNode, I think is going to be a really important thing going forward. So to give everyone clarity on what and isn't supported, and this is something that can also cascade throughout the ecosystem to be more easily serviced in the Explorer. So subgraph information can be like highlighted more clearly. As you can see, one key type here are the different types of networks. So as we're adding new networks, we'll be adding those are additional lines where currently only mainnet is fully supported. So those are two quite foundational ones. Getting into the meat is essentially the epoch block oracle. So this is essentially going back to that proposal from March, a component which keeps track of essentially the blocks which should be used to close allocations across different chains. So it's really a data availability problem, but essentially providing consensus and clarity on which blocks indexers should use, and essentially posting them on chain. There's, again, a lot of detail in here around the mechanism used. It's using a data edge and a sort of subgraph as an oracle. So there's some cool implementation stuff, and we're also this is something that's being actively tested on as part of the MIPS program. Actually, we had an issue this week where we had some issues with provider reliability, and so again, one of the benefits of testing things on testnet, and we're going to be essentially getting ready for mainnet. So introduces that sort of new technological thing, but also introduces a new governance thing, which the addition of new networks to the Epoch block oracle is going to be done by the council multi-sig. So again, it's just giving a bit more clarity and essentially governance approval to addition of new networks, because it is really unlocking quite an important thing, which is indexing rewards for new chains. So there are two things. It's a new technical thing, but it's also a new governance process, which is kind of tied to this here, but it's an additional actually on-chain action rather than just a governance vote. And then the last thing, which is really just a specification thing. So this is the edge, but a data edge is essentially a mechanism for getting data on-chain into a subgraph in a very gas-efficient way. This is what powers the block oracle, and essentially it's just really identifying the one which is that we're going to be using for the protocol initially for this one purpose, but we'll be using it for other things, I'm sure, in the future. And so quite a few things, some of them essentially just ratifying long-standing things, others introducing new functionality to the network, but it's pretty exciting. And yeah, questions, very welcome.
Perfect. Thanks, Adam. Right on time. Questions? Raise your hands.
I had a question. What does this do operationally to indexers supporting multiple chains? The Epoch block oracle, will that be made transparent with the indexer agent, or is there something else indexers should be aware of and start preparing for?
Yes, that's a good call out. So I think one thing we've definitely worked through here is to try and minimize the amount of disruption, obviously, for indexers. So I think one thing that indexers will have to be doing if they want to support Gnosis subgraphs will be to obviously have a Gnosis client that they can access, which will be configured via graph node. The other, I think most salient change that they need to make is to update their indexer agent configuration, essentially with the subgraph endpoint that that is essentially the Epoch block oracle subgraph. And then that will essentially be used to look up blocks when appropriate, that should be used to close allocations. There's a bit of and so when it comes to actually looking at block numbers to block hashes, it's set up, and so great work by the indexer and components working group just on making that sort of streamlined. Those two changes should be pretty much all you need to do, and the allocation should close using the block oracle on non-mainnet chains as if by magic.
Okay, anyone else? I just posted the link to that particular indexer agent config. That's what our MIPS indexers are using right now. Okay, we have time for final questions. Any other business? Anything else you guys want to discuss or ask questions? I don't see anyone raising their hands. Okay, so first time in a long time, I think we're ending sooner. All right, so let's wrap it up here. Thank you all for joining. Be back to these calls in a month. Thanks all. Have a good day. See ya.
Thanks. Bye.
Thanks, Pedro.